Hey, welcome back to day 44. Today we're going to be looking at this game. I'm not going to show you how to play this, but I'm going to show you how to code this game. Oops. More specifically, the skill you're going to get today is how to read code written by others. That is a crucial skill for programmers, but I've never seen it covered in other courses. So what I'm trying to say is that we're not going to build this game ourselves. We're going to look at the finished code of this game, and I'm going to show you how you can use PyCharm to understand the code, to analyze it, and be prepared to collaborate with other people on that code. Being able to read code is a crucial skill because once you start working with Python, you are soon going to be given a program where you have to fix or add something or extend the program. And so before you do that, you need to understand what the code does. And to understand the code, you need to know how to read it. So we're going to do all that by using the code base for the game I just showed you. Also, this game was built using object-oriented programming, so classes, and that means we're going to review the skills you learned during the previous few days on object-oriented programming. So this is a great opportunity to expand and deepen your understanding of classes. So with that in mind, let's begin, and I'll talk to you in the next video. Hey, welcome to today's programming tool. This video is a continuation of today's series because here we're going to get the code we want to work on today. So as we said, we're going to be working on some existing code. We will try to understand the code. We will try to read the code and understand it. And when you want to do that, so when you want to work on other people's code, the first place to start is GitHub. So normally, that code will be stored in a GitHub repository, which is a remote repository. So the code is stored on github.com in the account of the author of the code or some other collaborators. So in that case, you want to get the code in your local computer, in PyCharm, for example. Now, there are two ways to do that. One is by cloning that code, and I showed you already previously in the course how to clone a GitHub repository. But there is another option, and that is fork. So what is the difference between cloning and forking? Well, you do cloning when you don't expect to contribute to that existing code. Let's say this user here has uploaded this code. Now, if you plan to just work on your own, to just get this code, run it, and you don't want to interact with this original author, then cloning is fine. But if you want to collaborate, if you want to contribute to this code, to make it better, then what you want to do is you want to fork this repository. So now let me show you how to fork a GitHub repository. So please find attached to the link to the remote repository you want to clone for today. So that's the link to this page, to this repository. So you want to clone my repository for today. In my case, I'll clone somebody else's repository since I'm on my own account here. So it makes sense to get somebody else's code. And you'll get my code, so I'm somebody else in your case. And so first thing you want to do is you want to make sure you are logged in into GitHub with your account. So let's say I'm logged in now. So I'll go to this repository, which I want to fork. So that's the user mx0c. In your case, it will be the user Ardet Sulca teaching. And mx0c is actually the original author of the code which builds the Mario game, which I showed you in the previous video. So to fork a repository, you want to go to that fork button. Press that. If you have forked that repository already, then you cannot create another fork. So since I forked this already, let me fork another repository which I haven't forked. So I just found a random repository. So again, you go to fork, and then you choose a name for this new repository. So what happens is that a new repository will be created in your GitHub account with reference to the original repository which you are forking. So you can leave everything as it is, press on create fork, and this will be a public repository and it's not possible to change that on GitHub. So when you fork somebody else's repository, that will be a public repository. So once you have that repository in your own GitHub account, you should see this description here. So it says forked from that user, and that's the name of the repository you forked. And then the next step is you want to get that repository downloaded in your computer. So for that, you want to go to code, press on that copy button, and then you want to go to PyCharm. And you want to close that existing project. That will show you this startup window. If you don't see this, open PyCharm again and this should show up. And then you want to go to get from VCS, paste that URL there. So that points to the forked repository. This is my account now. In your case, it should be your account, and press on clone. In your case, you should see another window here telling you if you want to install the Python libraries. So if the remote repository did have a file named requirements.txt, then you'd get that pop-up window and you can press on OK there. So that should install the requirements, the libraries that this app needs to function. Now, if you go to Git, you'll see all the commits that the previous users who have been working on that app have made. And you can make more commits here. So just change something from the code. Go to any file, just add some comment. Hey there. So that's change, right? You can press on the commit button. Let's say add commit. Press on commit. And you should see that commit in the Git tab in the commit list here. So that means that your code now is one commit ahead of the repository which you forked from. So what now? What if you want to add that addition to the very original repository? So to the repository of the other user. In my case, that would be this Serenity Valley game. So what if I want to contribute to this repository and tell this user, oh, I made some improvement there, I added a comment. How do I do that? Well, there are two steps. First, you want to push those changes to your repository. So if you go to Git and you check on Manage Remotes, you'll see that this is a repository now, which points to your own GitHub account. So when you do push now, you press on push, wait for the message here, pushed one commit, that was successful. Now if you go to your repository, so the forked repository, and you do a refresh of the page, you should probably see this message. So the branch is one commit ahead, and among these you'll see that I edited the entity.py file in my case. In your case, you perhaps edited some other files. And next to that file, you'll see the message, the commit message, and the time when you did that commit. So that was 5 minutes ago. So now the change you did, the improvement you did, is still in your repository. So you are the owner of this. Now, if you want to contribute this change to the original repository, which is listed down here, then you want to go to pull requests. So you want to make a pull request there, and then go to new pull request. Then in this page, you'll see an overview. Down here, you'll see the changes you did, and then you can press on create pull request. That's a commit message. Now in this dialog, you have the opportunity to write something, and this will be reviewed by the original user whose repository you forked. If it's just one commit, then you can leave the message of that commit. If there were multiple commits, you can write something else which summarizes all the commits you made. Once you have done writing the description and the title there, you can press on create pull request. If there are no conflicts with the code of the original repository, then you should get this message that everything was completed. So now, next is that you should wait for the author of the other GitHub repository to reply, so to approve or reject your changes, your commits. If they approve them, then your code, your changes will be added to their repository, and those commits will be listed here among the other commits. Right, so to wrap it up, what we did today is I gave you this repository and I asked you to fork this repository. You found the link to this attached in the lecture resources. So once you forked that to your GitHub account, then you cloned your forked repository in your local IDE, then you did some changes, made a commit, pushed the changes to your repository, and then you did a pull request to notify the other user that you made some changes and ask them if they want to approve those changes or reject them. And that's it. One more thing I want to mention before I close this video, the difference between cloning and forking. So in this video we used fork, but if you were working in a smaller team where you know each other, then you can just clone the repository of the other person, right? So let's say this is a repository of the other person, you can just get the link, go to PyCharm, close the existing project, open PyCharm again, this window should start up, get from CSV, paste that link there, and you'll clone that repository. And then you can just push, you can commit and push the changes directly, and those changes will be added to that original repository. And that user will give you access since they know you already. So you don't have to do forking or pull requests. You can just clone the repository, commit and push the changes when you're working in a smaller team. So that's what I wanted to cover in this video, and in the next ones we're going to work on that code of that game which I showed you earlier. Understand how it works, see how the code is built with classes and so on. So see you in the next one. Hey, welcome back. Today we have pretended like we want to collaborate with somebody else who has written some code, and so we want to add something to that code. So what we've done so far is we got access to the existing code by getting that code and cloning that on our local IDE. So I have the code of that app now. And so the next step is we want to familiarize ourselves with that code before we do any changes. So once you have the code in your computer, the first thing you want to do is to try to run the code, make sure it works. And of course, to be able to run the code, you should first install any necessary libraries. Now, when you clone the repository and the repository contains a requirements.txt file, then PyCharm might ask you if you want to install those files. You might have gotten a pop-up window when you clone the repository and you pressed OK perhaps. If you didn't press OK, then what you do is you'd want to install these requirements, these libraries from your terminal. So to do that, you can open the terminal and do pip install -r requirements.txt. Now I got an error which says there's no such a file in the local directory. That's because my terminal is pointing to another directory which is different than my project directory. So perhaps I need to just close this terminal window and open it again. So try again, pip install r requirements. Yeah, this time it recognized my tab key, so I can type in the name, press tab to auto-complete it, and then you want to press enter. And so in my case, I had installed these already, so I have all these requirements already satisfied. So Pygame, SciPy, and NumPy have been already installed. And you can see that what we installed is the exact versions of those library, the exact versions as they are in this file here. So that's the syntax when you want to specify. So the author of this app has created this requirements.txt file, and they have included the versions there as well. So the versions which actually work with this code base, with this program. Now NumPy is not here because NumPy is a dependency of SciPy. So actually when you install SciPy, NumPy will also be installed. So NumPy doesn't have to be here in the requirements.txt file, but pip will install it when it installs SciPy. Right, so once you install the requirements, then you want to run the program. Now, before you run the program, it's generally a good idea to go to the readme.md file, if there is such a file, and you want to take a closer look what the program consists of, and perhaps it says how you can run it. So yeah, there we have a section on running. So first you want to install the requirements, which we already did, and then you run it with Python main.py. You have some other information, such as how to create a standalone executable, and these are the controls, how to play the actual game, and perhaps some screenshots here, the dependencies, the libraries, and so on. So this readme.md file can also be found on the GitHub repository. It will be automatically displayed in here by GitHub. So all that information is the same as the one we just saw in PyCharm. And so main.py is the entry point of this program. So let's try to run main.py. And so the game seems to be working, perhaps you can try it. By the way, this game doesn't go to the very end. Perhaps the original author should know more about that, but that's something I wanted you to know. So once the program looks to be running fine, then the next step is to try to familiarize yourself with the libraries used in this program. And that is something that we'll do in the next video. So yeah, that's about this video, and I'll see you in the next one. Hey, welcome back. We will continue pretending like we're working with someone else, and we are now exploring the code written by that other person or group of people. So previously we got access to the code, we have it locally, and the next step in the process is to try to explore the project to see the directories and the files it contains, so that we have a general idea of how the program is structured. We don't want to be looking at the actual code right now. We just want to look at the files from the outside, to see the names of the directories, to make sense of how everything is organized. So as you know, there is the project directory, the main directory, which in my case it's named Super Mario Game. And the root directory contains other subdirectories and files as well. The files are these ones, so .gitignore compile.py, which is about converting this project into an executable .exe or .app file. So you would use that file if you wanted to convert the Python project into an executable. We have the main.py file, which is usually in the root directory directly, not inside any subdirectories. So usually you know that this is the entry point of the program, first because it does have the name main.py, that's a convention between programmers. So even if you don't read the readme.amd file, you know that this programmer has written the code that runs first in this main.py file. And we have the readme.md file, requirements.txt, and settings.json. In this file, usually you can store some general settings about the game. For example, when you run the game, you'll see that we have this settings here, so you can move around with the upper arrow keys. If you go to settings, you can turn the music on and off, or the sound effects on and off, right? So if I close this, if I go to settings now, these two values have changed to false. So run again, change those to on and on, exit, and this will be updated to true. So the user is actually changing these values through Python code, of course. So there's some file here which is affecting that settings.json file. Then let's look quickly at the subdirectory. We have this classes folder. So it's important that the other programmers have used meaningful names for these files. You'll see that in each of them you have a class defined. So because there are so many classes, the authors of this program have decided to write each class in a separate file, which is a good decision because otherwise you'd end up with a very long file. So it's better to organize the files in this way. So we have different classes here. In classes, then we have entities. Now in entities, we have the same structure. Basically, we have files and we have classes inside each file. And the class name corresponds with the file name. Now, I would have suggested here that this name be changed to something else. So instead of classes, this could be something else, depending on what classes you have included here. Perhaps interface, because each of these folders, as far as I can see, each of them have actually classes inside. So that's a class, that's also a class, and so on. And that's also a folder of classes. So it makes sense to have a more specific name for that folder. Also, my other suggestion would be that these names should be in lowercase, so the names of the files. Lowercase letters and underscores as well, in case when there are two words like coin, brick. And of course for classes, the recommended style is to use the camel case, so big letter in the beginning and then big letter in the other words, so capital letters. Let's move on. We have the img file. This is where all the pictures, the image files are located. So for example, we'll see that in items we have all these elements. So there are some Python files somewhere which are reading these images, and we'll explore those files later. And so these files then are rendered on the game. And we have other similar elements which are part of the game. And then we have levels. These are JSON files. These also contain data. So data, as we have talked before, data should be stored in external files, such as JSON, CSV, text files, databases. And that's what these programmers are also doing here. So we have different levels implemented in the game, as you'll see when you run the game and you go to choose level. We have level 1, 2 and level 1, 1. So that reflects to those two files there. SFX, that's the folder where the sound files are located, so audio files, such as what happens when you kill one of the enemies, or when the main character gets some power-up features, or bumping into another thing, or so on and so forth. We have sprites then, down here. These are also data, and these data point to the different PNG images, such as this here. So these are called sprites in games. And so tiles.png should be here, there it is. So those are the tiles, and you'll see that we have some X and Y here. So X is 3 and Y is 23. So that's about the sky background, right? So X is 3. That means 1, 2, 3 and 23 down. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these count for 2, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that piece of image, that will be loaded as sky. So there will be like different tiles of that image to make up the sky. We have bricks, x1, y0, so that would be x1, that means 1, 2, and so y is 0, so that's the first element, that's brick that will be rendered as part of the brick visuals. And so yeah, that's about the sprites JSON files. We have this folder which is empty, so we can ignore that. And then we have traits. Traits in this game are the features that the characters get. So like powering up, getting something new, and so on. So like being able to bounce, being able to go somewhere, jumping higher, and going left and right. So these are also created as classes. So with that, we have a better overview of what's going on in the program. So then the next thing is to go to the main.py file and understand how the program is running. And so in the next few videos, you'll see some features of PyCharm which allow you to actually study the code, to analyze it, to see the chain of methods, like how a method calls the other method, so you understand the flow of the program. So yeah, I'll talk to you in the next video. See you there. In the previous video, we took a look at the structure of the project. Now it's time to look inside the files to understand how the program works. And you want to start from the main.py file. So I'll close all other tabs and keep only main.py open in here. So what's happening here is that in the first line we have the Pygame library, and then we have all these classes imported from classes directory and from entities as well. So these two directories. So we have the dashboard class, level, menu, sounds, and Mario. That's just a variable. And so then we have this function main. So you have seen previously in the course that in main.py, in this file, we initialize the classes, calling the methods of the classes, and so on. And we put all that code inside an if name is equal to main code, which means that the lines will be executed when this file is executed directly, which means that the lines will be executed when this main.py file is executed as well. Now in this code there's a slight change to that. So the code is inside a main function, and then here that main function is being executed instead of putting those lines in here. Either way is fine. Right, so let's look at the main function. In the first line, there are some audio configurations being set up, and then here is where Pygame is initialized. So this is a function which initializes the Pygame engine, and then a screen window is created. We have the frame rate 60, then we use a dashboard class in here, pointing to the font.png file in the img directory. So dashboard is a class, and this is an instance of a dashboard. And dashboard refers to screen. So this is a screen instance, this is a dashboard instance. Now sometimes instances can be created by other functions or methods. So if you right click over this set mode function and then you go to implementations, you'll see that this is a function. So this function is part of the Pygame library. It's not part of this project. And this returns a so-called a surface object instance, right? So that's a dashboard instance, that's a surface object instance. Then we create a sound object instance. So everything is built using classes. That's what we call an object-oriented programming paradigm. We have the level. So when you start the game, you are choosing one of the levels here. So we have two instances of levels, and if you look at the level class, so if you want to see that class, you can right click over level, go to implementations, and that will take you to level.py, which is inside classes, and then you'll have the class level. And then you have the load level method, which opens the levels JSON file, which we saw earlier. So one of these files, right? Either that or that, depending on what level the user chooses. So let's go back to main.py. So we were at this point. So level gets screen, sound, and dashboard as arguments. You see here, so screen, sound, and dashboard. So these are parts of the init method. So when you create an instance, the init method is executed, and you have to pass all those in there. So screen points to this variable, sound points to that, and dashboard points to that. So these are instances. Remember, in the ticket reservation ticket class, we got a hotel instance as one of the arguments. In this case, level is getting these instances as arguments. Now you might ask, what about load level? Is this method being called in here? So who loads the level anyway, right? Well, if you do a quick search like load level, you'll see that this method is not being called in main.py. So for sure it's being called somewhere. So how can you know where this method is being called? To do that, you want to right click over the method. So we are in the definition of the load level method inside level.py. So right click there, and you want to go to find usages. So by usages, what is meant is the calls, where this method is being called, where it is being used, right? And you should see this window popping up here. Now this has this section, it tells you what methods you are inspecting here, and then you have this dynamic usages, one result. So this method is being called only once, and you'll see the hierarchy of the entities. So we have the Super Mario game folder, this is a project directory, right? Then inside classes, inside menu.py, inside the menu class, you see the C here. So we're inside the menu class, inside the check input method. And then if you click here, it should take you and highlight that line where load level is being called. So that's inside check input, right? That's the check input method here, which is part of the menu class inside menu.py. So that's a view of the check input method. But if you want to go to the actual file, which is menu.py, then you want to go here and right click and go to jump to source. And that should open up the menu.py file here in the editor, right? And your cursor will be placed in the methods where it's being called, right? And so that's the actual method. You can do the same for this check input method. You can right click and go to find usages, and this should open up again this view. So this is being used in the check input method, and so the check input method is being used inside update, which is a method of the menu class. So there, the program is calling the check input method. You can do the same for update, so right click here, go to jump source. This will open up the update method, which is in the same menu.py file, and you can see who is calling this method. So go to find usages, and we'll see this time that we got to the root of the issue. So we ended up in main.py file. So we see that menu.update is being called inside the main function of the main.py file. So you see main function, and that's the method. So again, to wrap it up, what's happening is that when you execute this main.py file, then this file is creating a menu instance here, and then menu.update is called, right? And menu.update calls the check input method, which calls another method. So if you go to the implementations of check inputs, you saw that this called that load level a method, which was somewhere in here, right? So that's one way to explore how a method is being called. Now I closed all the other files and kept only main.py here, and I'll show you another way how you can see the chain of calls. So let's look at the main.py file again. So we create the Mario instance, which is the main character. So just to make clear, so this guy here, which is moving, that's Mario, the red one, right? Now, we create the instance, but how is actually this character moving? Is there a method that is being called somewhere? So we see that Mario has a restart method, but that happens when something happens and the program restarts, the game restarts again. Else, we have this Mario update method. So the update method is what makes the character to start moving. So now we want to explore if this method actually calls other methods. So again, you can either go to the implementations, as we did, and check what methods this method is calling. So we have move Mario, move the camera, and so on. Or another way would be to right click here, go to find usages, and then you go to the call hierarchy tab. Now this option is highlighted, but if you reverse the hierarchy, if you do this, then you'll see the chain of calls. So if you go down here, so you locate the Mario update method, so which means that we have the main function first. This main function is calling all these other functions or methods. So for example, when sound is initialized here, up here, sound, that means init was called, right? And so Mario is also initialized, and then Mario.update is called, right? And then if you expand this, you'll see what the Mario update method calls on itself. So all these are the calls that happen inside the definition of the update method of Mario, so which I just showed you. when you go to implementations. So update traits and move Mario and so on. So all those you can see in here. And then you start to understand how this program is working, right? So there are many things that happen at the same time. We have this method which is called all the time. So while this loop runs, this loop here, this run every millisecond. So this method is being called every millisecond or so. And so we check for things like update the traits if Mario has gotten some superpowers, and then there's the method that moves Mario, which I would suggest that the programmers have named it just move, Mario.move, instead of using this camel case style. So this method is calling other methods inside its definition. Then we have a camera, which is an object also in classes.camera, that's the location. So classes.camera, that's basically an object which makes it possible to move the scene from one to another to show different objects and different backgrounds and so on. Then we also check for entity collisions, so we check all the time if Mario is colliding with other enemies like those mushrooms and so on. And so you can explore inside those methods, right? So what I'm trying to show you is an efficient way to explore the code. So having this hierarchy helps a lot to see how things are working instead of just reading large amounts of code. This is a better view, a better overview of the code. So as you can see, the benefit of object-oriented programming is that you can keep the actions separated in classes, and each class has its own methods, and different methods call other methods of other classes, and that's how everything fits together to make a program. One last thing I want to show you is also the structure tab. So if you are inside a file, let's say dashboard.py, and you press that structure tab, you're gonna see the defined variables and methods and classes in that current file. So for example, we have the dashboard class with this C here, and then we have these methods with M. And so we have other entities that belong to the dashboard class. So that's about the elements inside the file, and that was the elements that call each other. So that was some advanced inspection skills, and I hope you find this useful. And yeah, thanks a lot for following, and we're ready to build more programs now. So thanks a lot, see you later.